So here we are starting our notes on rational equations and applications, and this is the fourth module for Math 023. And we're going to start off with rational equations. And a rational equation is any equation containing one or more rational expressions. To solve a rational expression, begin by multiplying both sides of the equation by the least common denominator, or as we abbreviate it, the LCD. Then solve the remaining equation. If it's a linear equation, we'll isolate x. If it's a quadratic equation, which means to the second power, we'll factor it and then solve for x. We do have to, when we're solving rational equations, look for an extraneous solution. That's an E there. All right, an extraneous solution to a rational expression is any solution that, when placed into the original equation, results in a zero in the denominator. So basically, it makes our fraction illegal or not allowed, undefined, because you get that zero in your denominator. So here with A, we have our first rational equation, and we need to find the least common denominator. Currently, my two denominators are 2 and x. And remember, your least common denominator is the product of all your unique factors. And if you have variables, they're always raised to the highest power that you have. So our LCD that we're going to use here will be 2x. So what I'm going to do is I'm going to multiply everything in the equation by 2x. So I'm going to put parentheses around both sides and my 2x. Now, when you're working with your fractions, if it's easier, make it 2x over 1. And what's going to happen when I multiply by my common denominator is you should eliminate the denominator part of your fraction. And if I show you here, it's like we're using our distributive property here. So my first thing I'm going to do is 2x over 1 times 1/2. And if I multiply it, I'm going to get 2x over 2, but the 2's equal 1, so I'm left with x. And now I'm going to do 2x over, oops, let me erase that for us. 2x over 1 times 5 over x. And here, remember, if you have a numerator and a denominator with a common factor, you can simplify it out. When I multiply, it's going to give me 10x over x, but my x's will cancel, so I'm left with plus 10. And then here, 7 times 2x, my answer will give me 14x. And now what I'm going to do is just solve the equation. I am going to combine my x's first, so I'll subtract x from both sides. And that gives me 10 equals 13x. We will divide by 13 on both sides to get x by itself. And I get x equals 10/13. So we have x equals 10/13. And what we want to do is double check to make sure that if I plug in 10/13 into my equation up here, that it will not give me 0. 5 divided by 10/13, no matter what, will not give me a 0. So my solution is acceptable. We're going to move on to B now, and we need to find a common denominator to multiply everything by to eradicate the denominator in our equation. And for my numbers 4 and 6, my LCD could be 12. And then we have x, so it'll be 12x will be my LCD. So I'm going to multiply everything by 12x. Or again, if it helps you to visualize it, make it 12x over 1. All right, so to show you the multiplication, I'm going to do 12x over 1 times 7 over x. You're going to multiply it times every single part. And that's going to give me 84x over x, but those two x's equal 1, so it gives me just 84. So I'm going to write that down here. I have 84. Keep my minus sign. And then we're going to do 12x over 1 times 3/4. And that will give me, I'll have 36x over 4. But that simplifies. 4 goes into 36 9 times, so I get 9x. So minus, fit it on there, minus 9x equals, and then if I do 1/6 times 12x over 1, you get 12x over 6, which 6 goes into 12 2 times, so I get 2x. So there's my equation without fractions. It's much easier to solve. And I'm going to move, to solve it, it's a linear equation, just every x is to the first power. I'm going to start by moving 9x over to the other side. Since they subtracted it, I will add it. So that's going to leave me with 84 equals 9, 10, 11x. I will divide by 11, and I get x equals, and because it doesn't go in evenly, I am going to leave it as a fraction, so I'm going to leave it as 84 over 11. And again, what you want to do is you want to go back and check your answer here, put it into your equation where you have the fraction. Since x is on the bottom there, put it in blue. I want to make sure, will 84 11ths and 7 ever give me a 0 in my denominator? And it won't, so it's not an extraneous root. That is our solution. All right, so now we're going to start with C. And here, it's nice to find my common denominator because I only have one denominator, and that is x minus 4. So that is going to be my LCD. So my LCD here is going to be x minus 4 for C. So what I'm going to do is I'm going to multiply everything here by x minus 4 on both sides of the equation. Smush it in there. All right. Now, when we do this, the first example I have 4x over x minus 4, and I'm going to multiply that by x minus 4 over 1. Remember when we simplified rational expressions, if you have a numerator and denominator with the same thing, they cancel out. So that's nice. So for my equation, I'm left with just 4x there. Now I do have to do x minus 4 times 5. And in this case, it's really going to be our distributive property there. So we're going to get plus 5 times x is 5x. And then negative 4 times 5 will be negative 20. So minus 20 will equal. And then again, over here, I have 5x. Let me put it right here. 5x over 1 times x minus 4. Oh, 5. Sorry, let me fix that. It is. All right, let's get this right. So it is 5x over x minus 4. And we're going to times that by x minus 4 over 1. So again, with my numerator and denominator, they cancel out, and I'm left with just 5x. All right, so now we're going to simplify the equation and solve it. On the left-hand side, 4x plus 5x will give me 9x. So I have 9x minus 20 equals 5x. And then I'm going to combine my x's. So first I'm going to subtract 5x from both sides. So that will leave me with 4x minus 20 equals 0. And then I will add 20 to both sides. So now I have 4x equals 20. Divide by 4. And I get x equals 5. Now again, I want to check for extraneous roots. And if I do that, if I plug in a 5 up here with 5 minus 4, 5 minus 4 is always going to give me 1, not a 0, so it works. It is not an extraneous root. We're good. Okay, I'm going to erase a little bit here just so we have some space. Okay. Now we are going to work on D, and I'll put it in red since we did blue with the other one so you can kind of see the difference. Okay, so again, my LCD is going to be my common denominator of x minus 3. So I'm going to multiply everything here by x minus 3, or x minus 3 over 1. And if I write it out, I have x minus 3 over 1 times 3 over x minus 3. And again, with these terms, it's nice because my numerator and denominator cancel each other out. They equal 1. So I'm left with 3 in my equation. And I'll keep my plus sign. Now, it's going to be 2 times x minus 3 as well. It's not a fraction. So we'll distribute, and we get 2x minus 6. And then over on the other side of the equal sign, on the right side, remember, our x minus 3's cancel out, so we're left with just an x. So let's combine like terms on the left. 3 minus 6 will give me a negative 3, so I have 2x minus 3 equals x. And then I'm going to solve the equation. So let me combine x's. I'll subtract x from both sides. And that's going to leave me with x minus 3 equals 0. And then to solve the equation, I'll add 3 to both sides. And I get x equals 3. So there's my solution. However, if I check this, x equals 3, if I go back to my denominator, if I have x minus 3 and x is 3, if I do 3 minus 3, what do I get? I get 0. So even though this is a solution after we clear the equation, because it makes our denominators 0, my answer is no solution because x equals 3 is an extraneous solution. So you do always want to check, but the answer would be no solution here. All right, so here, before we find our LCD, remember, you want to make sure that both or all your denominators are in factored form. X plus 2 is, but 2x plus 4. Remember, we can factor that. We can pull out a 2 and make it 2 times x plus 2. Which kind of helps us because now we have two factors here. Our denominator is going to be the product of all of our unique factors to the highest power. One of our factors is x plus 2. The other is 2. So our LCD is going to turn out to be 2 times x plus 2 because I'll put those two together. So now I'm going to multiply everything by my LCD, which is 2 times x plus 2. All right, and so if we do the work down here, if I do 2 times x plus 2, and again, put it over 1 if it helps, times 3 over x plus 2. My x plus 2's will cancel, and I'll still multiply together the 2 and the 3, so it will give me 6. Plus, now I'm going to do 1/2 times 2 over x plus 2, or times x plus 2 over 1. My 2's will cancel out here, and I'm left with x plus 2. And then our equals. And then we have our equals sign here. And when we do 7 over 2 times x plus 2 times 2 plus x plus 2, our denominators cancel out, and we're left with a 7 here. So combine your like terms, and we're going to get x plus 8 is equal to 7. So to solve it, I will subtract 8 from both sides. I get x equals a -1. When I go to check it, -1 plus 2 will always give me a 1. So I'm never going to have a 0 in my denominator, so that is a perfectly good solution. All right, now f. The first two denominators are completely factored, but x squared minus 1, remember that's your difference of perfect squares. So we can factor that into x plus 1 times x minus 1, which actually ends up giving me my common denominator because I have a factor of x minus 1 here in the first fraction, x plus 1 in the second fraction, and they're both put together in the third. That's my LCD. So I'm going to multiply everything here by my LCD, which is x plus 1 times x minus 1. All right. So for our first one, we're going to do -3 over x minus 1 times x plus 1 and times x minus 1. So again, get rid of that denominator. My x minus 1's will cancel, and I'll be left with -3 times x minus 1. So that will be -3 times x minus 1. And I'll multiply it out in a second. We'll put our plus sign there. For 5, we're going to have 5 over x plus 1 times x plus 1 times x minus 1 over 1. And my x plus 1's cancel, and I'm left with 5 times x minus 1. And then equals. Now for this one, it's nice because in my answer here, my denominator is my LCD, so they would cancel out, and I'm left with just x minus 2 here. So now I need to simplify. First I'm going to distribute, and it's going to give me, so when I distribute, I get -3x plus 3, because, oh no, this right down here should be x plus 1, not x minus 1. There we go. That's okay. So it'll be -3, and then plus 5x minus 5 equals x minus 2. Combine like terms, -3x plus 5x will give me 2x. -3 minus 5 will give me -8, or -8 equals x minus 2. And then we will subtract x from both sides. So I get x minus 8 equals negative 2. Add 8 to both sides. So I get x equals a 6. And again, to check it, if I plug in 6, 6 minus 1 up here would give me 5. And 6 plus 1 will give me 7. So I'll never get a 0 in my denominator, so it works. So now we're going to look at applications of rational equations, aka word problems. We're going to start off with a word problem written out, which I think are probably harder than some of the other ones because you're writing the problem from words, and sometimes it's just a little bit harder. But the problem says a number plus 4 times its reciprocal equals negative 5. Find all possible numbers that satisfy this statement. Well, we're finding a number. We don't know what a number is, so that a number is going to be our x. Plus 4 times its reciprocal. If you call a reciprocal, like if I had 2/3, my reciprocal is when I flip it and I get 3 over 2. Right now I have x, or x over 1. My reciprocal would be 1x. And we need to do 4 times that. So we're going to put plus 4 times 1 over x. And then it equals a negative 5. Now to help us out here, I am going to simplify this by multiplying the 4 over 1 times 1x. So it's x plus 4 over x equals negative 5. And this is a rational equation. We need to clear our equation of our fractions. We only have one fraction. Our denominator is x. So I'm going to multiply everything here by x, or x over 1. So the first one is just going to give me x squared. And then when I do x times 4 over x, remember those x's will cancel out. It leaves me with just plus 4. And then negative 5 times x will be negative 5x. Now, to solve this, it is a quadratic. We have to that second power right there. So we have to set it to equal to 0 and factor. So we're going to have, I'm going to add 5x to both sides to make it equal to 0. And I am going to write it in descending order. So we're going to have x squared plus 5x plus 4 equals 0. And we do need to factor that. We need factors that multiply to get 4 and add to 5. So 2 and 2 won't work, but 4 and 1 will. So we're going to do x plus 4 and x plus 1 equals 0. And then set both of those to 0, so x plus 4 equals 0, and x plus 1 equals 0. Subtract 4 from both sides to get x equals negative 4, and then subtract 1 from both sides to get x equals negative 1. So my two solutions would be x equals negative 4 and negative 1. So our next problem is 7 times a number minus 6 equals the reciprocal of that number. And again, we don't know what a number is, so a number is going to be our variable x. So 7 times a number would be 7x. Then we have minus 6 equals, or equal sign, the reciprocal of the number. So the reciprocal of the number, remember x is our number, the reciprocal would be 1 over x.
And here again, we want to clear our equation of our fractions. So we are going to multiply everything by our only denominator, x. So we'll multiply both sides by x, or think of it like x over 1. So 1. All right. So when we do that, with x over 1, we'll have 7x squared minus 6x. And then over here, remember your x's will equal a 1, so we're left with, or cancel out, so we're equal with a 1. It's a quadratic, so we have to make it equal to 0. So we will subtract 1 from both sides. So I get 7x squared minus 6x minus 1 equals 0. We'll go ahead and do our box method to factor, because it is a hard trinomial. So my 7x squared will go here. My 1 will go there. When I multiply my a times my c, it gives me 7. My only two factors of 7 are 7 and 1. So I need to make a 6, a negative 6. So we're going to do a negative 7 and then a positive 1. I'll put a plus sign there. So when I factor across, that's going to give me 1 and 7x across this way. Now when I go up, I'll have x, and when I go up this way, it'll be just 1. So when I factor it, I get x minus 1 times 7x plus 1 equals 0. And then again, remember, set each factor equal to 0. So x minus 1 equals 0, and 7x plus 1 equals 0. So for the first equation, I'll add 1 to both sides. So I get x equals 1. And then here, I will subtract 1 from both sides. So I get 7x equals negative 1. Divide by 7, so x equals negative 1/7. So my two solutions for the equation are 1 and negative 1/7. Okay, so here we're looking at similarity in geometry, and we're assuming that the pair of triangles below are similar, which means that their angles would all be the same measure and their sides would be in the same proportion to each other. And because of this, and we want to find the missing side, we can use a proportion to help us solve that. So what I'm going to do to set up my proportion is I'm going to take first corresponding sides. So the 4 inches and the 28 inches, they're corresponding sides on the triangle. They're the same sides. They just obviously have different lengths. And I'm going to make that into a ratio. So I'm going to do 4 over 28 equals, and then I'm going to use the same ratio with the other corresponding sides on the other side, which would be 6 and then x. And because I put the 4 on top, I'm going to put the 6 on top. So keep the small triangle on the top, large triangle on the bottom. And then here, we can, to solve it, just solve it like a proportion. So cross multiply and divide. So when we cross multiply, you get 4 times x, which gives me 4x. Keep my equal sign. And 6 times 28 equals 168. And now it's like a multiplication equation, so to solve it, I will divide by 4. And I will get x is equal to 42. And that's our missing side. We're going to do the same thing with this problem here. Now we're going to find missing side B. Now, they did give us extra sides. We don't need every single side here. We need one pair of corresponding sides where I know both the measures, and then my missing side and the corresponding side. So I can start off with my 20 over B, or make it x, doesn't matter. All right. And then I need a pair of sides where I know it. So I can either use like the 6 kilometers and the 1.5 kilometers, or I could use 10 and 2.5. It doesn't matter which one we use. Let's go ahead and we'll do the 10. because the 10 is with the 20, I'll put it on top, and then I'll put my 2.5 on the bottom. So cross multiply, and when I do that, 20 times 2.5 will give me 50. And then b times 10 will be 10b. Divide by 10, so b equals 5. And that's all you have to do. So here's our last one with the geometry and finding a similar or a missing side from a similar pair of figures. Now we have rectangles, and we want to find the missing side. So I'm going to start off with my one known ratio, which is 12 over 5.2, because those are corresponding sides. They're sides that match up. And then it equals, and then my unknown side is S over 3.6, which matches up with it. And then we just cross multiply. So I will end up with 5.2S, and that is an S. It looks like a number, so if you want to make it an X, you're more than welcome to, so you don't get confused. Then I'm going to do 12 times 3.6, which gives me 43.2. And then I will divide both sides by 5.2. And it gives me S equals 8 31/100. So our last two problems are work problems. And here our first one says 2 pumps are used to drain an in-ground swimming pool. If a larger pump can drain the pool in 4 hours, while a smaller pump can drain it in 9 hours, how long would it take if both pumps are used together? Now what we need to do is make a little chart here. And we're going to start off with, we have pump 1. Then we have pump 2. And then we have together. All right. And pump 1, total time is 4 hours. Well, a smaller pump takes 9 hours. And then we don't know together, so that's going to be our X. So we have total time in one column, and then we're going to take time per hour, or how much it drains per hour, really. Not really time per hour, but how much it drains per hour. Now, per hour, pump 1, if it takes 4 hours total, can drain 1 out of 4 gallons, or 1/4 of the pool, not 1 out of 4 gallons. But pump 2 takes 9 hours to drain the pool. So in 1 hour, it can drain 1/9 of the pool. Now together, we don't know how long it'll take, but it'll do 1 out of X. And actually, this last column here, this is going to be your equation. So we're going to look at it and break it down per hour, and that'll tell us how much it'll take total hours. So we're going to do 1/4 plus 1/9 equals 1 over X. Now we do need to clear our equation of fractions. So our common denominator here, if we look at 4 and 9, we can use 36, and we have X there. So our common denominator is going to be 36X. So we'll multiply both sides by 36X. And just to kind of show you my work, I'll do it right down here. 36X over 1 times 1/4 will give me 36X over 4. 4 goes into 36 9 times, so I'll have 9X plus, and then we'll do 36X over 1 times 1/9, get 36X over 9. 9 goes into 36 4 times, so you get 4X. And then over here, remember my X's will equal a 1, so they cancel each other out, and you get 36. So now we just need to solve it. It's a linear equation, so that's nice. Add 9X and 4X together, it gives us 13X which equals 36. Divide by 13. And when we divide, you get 13 goes into 36 2 times. You can't simplify it as it is, so you could leave it as 36/13, but that doesn't really help us time-wise. So I'm going to make it a mixed number, and it becomes 2, because 13 goes into 36 2 times, which is 26. If you subtract 26 from 36, you get 10/13, and that is total time or hours. So it takes 2 hours and 10/13 of an hour, which if we wanted to convert it to minutes, we could multiply it, set up a proportion, and solve it that way. But we don't have to. We can stop here. All right, we have our last one here, and this is Bob can paint a fence in 5 hours, while his assistant Drew can paint the same fence in 8 hours. How long would it take them to paint the fence if they worked together? So we're going to start off, we are going to look at, we have Bob first. And we know that it takes him 5 hours, or for total time, in part of an hour, it would be 1/5 of the fence can be painted in an hour. We have Drew. It takes him 8 hours, or for 1 hour, he can paint 1/8 of the fence. And then we'll do together. It takes them, we don't know how long yet, that's what we want to figure out, so it's x. But in 1 hour, they can do 1/x of the fence, or 1x. So again, this is our equation right here. So we'll do 1/5 plus 1/8 equals 1/x. And we need to clear our equation of our fractions. So 5 and 8, my common denominator there would be 40. And we have x, so it's going to be 40x. That will multiply everything by. So again, when I do my work, 1/5 times 40x over 1 will give me 40x/5 when I multiply. But 5 goes into 40 8 times, so it's 8x. Keep my plus sign. And then 40/x over 1 times 1/8 gives me 40x/8. 8 goes into 45 times, so we get our 5x. And then over here, my x's will equal a 1, so we're left with 40. So 8 plus 5 is going to give me 13x equals 40. Divide both sides by 13. So x equals, let's see, 40 divided by 13. 13 will go in 3 times, which is 39, and there'll be 1 out of 13 left over. So it'll be 3 and 1/13 hours. And again, we can stop there. They didn't ask us to convert it to minutes.